Hello. In this video, we're going to go through labeling, naming, and classification techniques when working with triangles. Now, by no means is this video going to go through all techniques out there. We're going to go through a couple commonly accepted ones, and a lot of the ideas we're talking about here can actually be extended to shapes that are not triangles. And we'll talk about that in a later video. So, you'll notice here I have 4 triangles. Let's imagine I wanted to communicate something about one of these triangles to someone. Well, if that was the case, it'd be really helpful if I had a name for each of the triangles. So one way to name a triangle is to first label each vertex with a capital letter. So if I take this first triangle right here, if I name each of the vertices with a capital letter, then what I can say is that this is angle A, this is angle B, and this is angle C. So this triangle would be called triangle A, B, C. Now you don't have to necessarily write these in alphabetical order, but it is strongly encouraged. It's kind of just being polite that we put these in alphabetical order. But it's good to note that triangle CAB is the same as triangle BCA is the same as triangle ABC. So one way to label angles is by labeling them with a capital letter positioned outside of the triangle. An important thing to take away from this as well is that if I'm talking about this angle, I could say to someone, well, let's talk about angle A. Well, another way to discuss angle A is to use 3-point notation. So 3-point notation is where I use three vertices, and the angle I'm talking about is the middle vertex. So if I talk about angle A, I could also say angle CA. B. So if I'm interested in the angle A, I could say angle CAB. Alternately, I could say angle BAC. It doesn't matter if B or C is first. All that matters is the angle A is contained inside. This naming convention isn't as useful for triangles, but when we're dealing with compound shapes, that is shapes put together, it becomes very useful. So if I come over to the second triangle here, well, I could name this. I could name each vertice here. So let's call that D. Let's call this vertex E. And we'll call this vertex F. So this is angle D, angle E, angle F. And this therefore would be called triangle DEF. Let's come down to the triangle down below here. And let's call this vertex H, we'll call this vertex I, we'll call this vertex J. So this would be triangle HIJ. So now let's come to this last triangle, and let's talk about the 2 other naming techniques we can use. Another way to name angles is to use either Greek letters or small case letters. When you use either of these naming techniques, it's important that you put the letter inside the triangle. So let's say I want to discuss this angle right here. I could put the Greek letter just inside the angle, and now I know that this is angle alpha. Remember, this letter is the Greek letter alpha. I could likewise put a small letter inside the crook. This would be angle X. This would be angle Y. The preferred method, though, for what we're doing is going to be by naming capital letters. Now let's talk about labeling sides of triangles. So this side here can be set as side AB because I just take the 2 endpoints. But sometimes I want to just use a single letter to represent this side length. And the strategy we use is we go to the opposite angle. So if this angle here is C, I go to the opposite side, which is directly across the triangle, and I name this with a small case letter of the opposite vertex. So if this is vertex B, or angle B, I come directly across, and this is side B. If this is vertex A, I come directly across, and this is side A. This side is said to be opposite of A. This side is said to be opposite of C. This side is said to be opposite of B. can do the same thing here. This is angle D, this is length D, this is angle E, this is length E, this is angle F, this is length F. If this is angle H, this is length H. If this is angle J, this is length J. This is angle I, this is length I. This is a very commonly used convention when working with triangles, and it's really important that we adopt this because this is going to make it easier to communicate ideas. You'll notice here in this triangle, it's not going to work as well. And we'll talk about this in greater detail about when to choose different naming conventions as we move forward. Picking the best choice is something that just comes with practice. The next thing we want to talk about is classification of triangles. And we have two ways to kind of classify a triangle. We can classify a triangle based on an angle consideration, or we can classify it on a side angle classification. So let me explain what I mean by that. We have what are called acute, obtuse, and right triangles. Acute triangles are triangles where all the angles are less than 90 degrees. Obtuse triangles are triangles where one angle is greater than 90 degrees. And right triangles are triangles where one angle is equivalent to 90 degrees. So if I come up here, let's start by classifying each of these triangles in terms of an angle-based classification. So if I come up here, we take a look. Well, this is obviously a right triangle because I see that angle C is 90 degrees. That's what this square means. If I come over here, this angle is this triangle is an acute triangle because all the angles are less than 90 degrees. Now you might be noticing something here since they're all equal, but we'll come back and talk about that in a moment. If I come down here, I'll notice that again all the angles are less than 90 degrees, so this is an acute triangle. If I come over here to this triangle, even though I don't know what this angle is, I can be confident that this is an obtuse triangle. Now, it's really important, and I want to stress this point here. You can't draw any real conclusions about any of the side lengths or angles if information isn't given. Remember, diagrams are not always to scale, and so it's important that even if two sides look the same or an angle looks acute, be very careful about drawing conclusions unless the diagram says this diagram is drawn to scale. So that's how we define triangles based on an angle-based classification. Now let's look at side angle classifications. Well, side angle classifications, we have three types. We have equilateral triangles. Equilateral triangles where all sides and all angles are equal. And so if I take a look at this case here, I see that all the angles are equal. And if I know all the angles are equal, I can then say all the sides are equal. So therefore, this is an acute equilateral triangle. Now, people don't say acute equilateral triangle, they just say equilateral triangle. And that's perfectly acceptable because all equilateral triangles would be acute. The next type of triangle we want to talk about are called isosceles triangle. These are triangles where two sides or two angles are equal. So here I see that two angles and two sides are equal, so this is called an isosceles triangle. So we say this is an acute isosceles. Let me try and spell it again. Make sure you can spell this word. I-S-O-S-C-E-L-E-S. This is an acute isosceles triangle. Now, again, people don't often will say acute isosceles triangle, but if we really want to be specific about this triangle, we need to put the word acute there because you could have an isosceles triangle with an obtuse angle. The last type of side angle classification is called a scalene triangle. This is a triangle where no sides and no angles are equal. So if we take a look at this last triangle here, we see this is obtuse, and I'm guessing based on this diagram that alpha is an obtuse angle, And since I have no information about the sides or angles, I can't assume any are equal. So this is an obtuse scalene triangle. So if we come back up here, we see that this triangle ABC is right, but it doesn't necessarily conform to any of these three. Oh, sorry, it's not necessarily equilateral. It's definitely not equilateral. It's not necessarily isosceles, so I would assume this is a scalene right triangle, or a right scalene triangle. So I've talked quite a bit about here, and what's really important with this type of practice is just to practice it. Practice using the correct vocabulary, talking about triangles using this correct terminology, because in doing so, you're going to find it easier to communicate ideas to your peers, as well as you're going to find interesting techniques to solve more challenging problems. I hope this video helped.